So in this video, we're going to be learning about if statements in C. So what an if statement is it's part of something in a programming language called control flow, or decision making. It's the way a program can make decisions and do different things based on the output of those decisions. So for example, I could say, if today equals Wednesday, do something or else do something else. So then depending on what day it was, the program would do something different. So I can make the program do different things depending on whether the condition is true or false. So what we create an if statement is we create the if keyword, then we put two parentheses, and in here we put our condition. So I'll just write condition for now. Then we surround it in curly brackets, as you do in a function in C. So we surround our if statement in curly brackets, and in the first set of curly brackets we say if the condition is true, then we run here. So we'll just write if true. And then we'll say if we want the condition to be false, we'll just say else, and then we'll say if false. So this means if this condition evaluates to true, we'll run this chunk of code, and if the condition evaluates to false, we'll run this chunk. So let's say if 1 equals 1, then we'll say printf correct, and then we'll say if 1 doesn't equal 1, printf incorrect. So obviously since 1 equals 1, we're only going to see correct, but if for some reason it wasn't, we're going to see incorrect. But for now we'll just see correct when we run this, so we'll say gcc learn.c-o learn. You see we get correct echoed out to us. If I change this to if 1 doesn't equal 1, which that's going to make this first condition false, which means we're going to run this second condition. So this also brings us on to operators. And see there's different types of operators. There's the equals sign, which is used for assignment. There's the double equals, which is used for comparisons. There's the exclamation equals, which is used for comparison that you want to be false. There's also less than or greater than equals, and there's less than equals. So if you're comparing two numbers, for example, there's also less than and greater than on their own. And there's also ordinary operators like plus, minus, divide, multiply, and there's also binary operators, but we'll not go on to them at the moment. We'll move on to them later. So as you can see, here's our condition. When we run this, what we should get is incorrect echoed out. You can see it says incorrect. What you can also do with an if statement is you can have nested if statements. So if this is false, we're going to run this else block, and then within this else block, we can have another if statement that says if 2 is let's say greater than 1. Then we'll run this. So say printf correct second block. This will tell us that it's the second block that ran. We run this, we get incorrect, and then we get correct second block. We can also have an else statement in here. So let's say printf another incorrect answer. Run this again, we get the same output as before. But if we change this to a less than sign, this first block will evaluate false. So we're going to run the second block, which is the else block. You can see we get incorrect, and we get another incorrect answer printed out to us. C has more than just if statements for decision making. It has something called a switch statement. So we use the switch statement like this. So in the switch statement, you put your condition up here, and then you put your case statements below it. So you say case, and say let's say case 1. Then we're going to run this code. So printf case 1, and then we're going to say case 2. Oops, printf case 2. And then finally, we're going to have a default case. So what this does is if the condition evaluates to 1, then we run this first case. If it evaluates to 2, then we run the second case. And if it evaluates to neither of the first two, then we'll run the default case. You also have to put a break tag underneath to break each case, because otherwise when it runs the first case, it'll run all the cases below it. And if it runs the second case, it'll run all the cases below it, unless we break out of the switch statement. For the default case, you don't need a break statement because since it's at the bottom of the switch statement, it'll automatically the program will automatically break out of it anyway, but you can put it if you want, but it's a bit redundant in the default case. So let's have a condition that evaluates to 1. So let's say 10 minus 9. And what we'll get is 1, so we'll get case 1 will run. You can see it says case 1. Let's say 10 minus 8, we'll get 2. Let's do 10 minus 3, we'll get 7, which is none of the first two cases, so we'll get the default case, which is default. So what I'm going to do now is I'm going to remove these break statements and show you what happens. Whoops, we need to change this. So we're going to make it 10 minus 9 to run the first case. So you can see it ran the first case, but it didn't break out of the switch statement. So what it did is it ran the second case, and then it ran the default case. So you need to be careful when you're using a switch statement, because even if your case runs, if there's cases below it, or there's a default case that hasn't run yet, these will just fall through and it will just keep running them as well. So you need to make sure you leave a break tag below each case, unless you specifically want each case to run, unless you want more than one case to run at a time. There's also one more way of doing decision making in C. This is sort of a shorthand if statement. So we can say 10 equals 10. Then we have question mark. Then we have our first, actually, okay, I'll just do it like this. So we'll have an if statement, and we'll say 10 equals 10, or else, and we'll have a printf in here. Oops. Printf, correct. I spelled it wrong, it doesn't matter. False, just doesn't matter. And then down here we will, or actually up here we'll have the other if statement. So there's sort of a shorthand way to write an if statement, which is you put the condition here, then you put a question mark, and then you put your first block, which would be the correct block. So if you have a condition of values to true, it'll run this expression. So I'll say printf correct b1 correct, and we actually want a semicolon, and then we'll have a colon, and then we'll say printf incorrect. And that should be it. So what we're going to get is we're going to get both of these printed out at the same time because we've got them both running. So let's run this and print. So we get correct b1 and then we get correct below. That's because 10 does equal 10, so this first condition, or this first expression is being executed, and this second one isn't. But if I say 10 doesn't equal 10, you'll see we'll get the second expression instead of the first one, so we get incorrect and then we get correct. Because this one is completely on its own. It has nothing to do with this first expression. These are just two different ways of writing basically the same thing if I change this to equals. So these basically are the exact same. They're just different ways to write it. This is just a quicker, shorter way to write an if statement in C, and this is sort of an easier to read version that's longer to write. And it just depends on your personal preference which one you're going to use. So that's it for this video, and I'll see you next time.